Well, hi there. Now that we've reviewed a little bit of the right triangle trigonometry, especially and those special right triangles, let's put that to use a little bit with some simple word problems. And a lot of times, when we're dealing with right triangle trigonometry, we're dealing with angle of elevation. Whoops, that was supposed to be a highlighter. Angle of elevation and angle of depression. So we've got kind of two different ideas here. Let me get my highlighter going. Angle of elevation and angle of depression. So I think we can all imagine, a person standing looking at the top of a tree. And so the angle of elevation would be considered this angle. It's labeled X right here. The angle of elevation is always going to be looking up. Right, so that's going to be when we think of the word elevate, we think rising. So the angle of elevation is always going to be a looking up angle. Now, the angle of depression is where things get a little bit confusing. So if we imagine a bird, right, sitting on top of this tree here, it's a very round bird, but it's there. The bird could look straight out, right, at a horizontal and see, straight across the rest of the world. If the bird wanted to look at this person, he would have to tilt his head down. And so it's that angle here between that horizontal and the view perspective that is actually the angle of depression. So if we think about this scenario in terms of a triangle, the angle of depression is not the inside of the triangle. It's actually outside of the triangle. Um, so this would be looking down. So a lot of mistakes that happen in word problems like this involve the angle of depression because we want it to be within the triangle, but it's actually not. Now, if we were given a word problem like this, say that the angle of depression was 35 degrees, right? The bird tilted his head 35 degrees. Now, we could, knowing what we know about right angles, figure out this inside angle, right? We would do 90 minus 35, and we would get that this inside angle is 55 degrees. Now, if that inside angle is 55 degrees, and we know that we have a right angle at vertex C, that means that x is equal to 35 degrees, right? On the inside of a triangle adds up to 180 degrees. But what do we notice here? Well, this is a really helpful idea, I think, is that the angle of depression um, is always equal to the angle of elevation. So when it comes to drawing pictures here, and this is something I really encourage when you're dealing with questions like this, is to actually draw out the scenario. Keeping that in mind, that the angle of depression and the angle of elevation are actually equivalent angle measures can be really helpful. So let's practice this just a little bit. So we have a tower. A tower casts a shadow that is 60 feet long when the angle of elevation of the sun is 65 degrees. So angle of elevation is 65 degrees, and we want to know how tall is the tower. So I'm going to draw just a quick little picture here. Right, I've got my tower, and then the tower has a shadow that is 65, not 65 feet long, 60 feet long. And the angle of elevation with the sun is 65 degrees. So this inside angle here is 65 degrees, right? Because that's looking up at from the end of the shadow to the top of the tower. And then we don't know how tall the tower is, so I'm going to call that missing value x. So if we look at our picture here, we've got the tower, we know that there's 65 degrees, and we know that we have one measurement of 60 feet. Now, if I think about these two sides here, the tower and the shadow, well, those two sides actually form the sides that are opposite and the sides that are adjacent to that 65-degree angle, which means I can use tangent here. This tells me that the tangent of 65 degrees is equal to the opposite over the adjacent side, x over 60, right? Opposite divided by adjacent is the tangent here. So tangent of 65 degrees equals x over 60. Now if I want to get x by itself, right, I multiply both sides by 60. So I get the new statement that 60 times the tangent of 65 degrees is equal to x. And I can plug that entire left-hand side into my calculator. Remember, I suggest either using a TI, a handheld calculator, or Desmos Scientific, not Desmos Graphing. Desmos Graphing actually won't be really helpful here. And we'll talk a little bit about that next week, why that is. But if I plug this into either one of my appropriate calculators, I get x is equal to 128.67 with a little bit of rounding feet tall. That is how tall the tower is. So once I have my picture and I can kind of break it down into what sides we're dealing with, I was able to use tangent pretty easily there. So we're going to do one more example together, and then I'll let you practice on your own. So Matt is a real smart guy. He's standing on top of a cliff 305 feet above a lake. Terrific, Matt. So here's Matt, and here's the cliff he's standing on, and then here's the water down below. So the measurement of the angle of depression. All right, so now we have an angle of depression to a boat on the lake is 42 degrees. So I'm going to put my boat here. It's got a little sail, otherwise you wouldn't know it's a boat, right? And the angle of depression. So when Matt puts his head down to look at the boat, remember it's not the inside of the triangle, it is the outside of the triangle. This is 42 degrees. So I can do this a couple different ways. Oops, I should label my other information. He is 305 feet above the lake. I apologize if you're hearing a lot of extra noise. My puppy dog Louie is helping me make the video today. And we want to know how far the boat is from the base. So we want to look at what is that horizontal distance there. So we could do this a couple different ways, right? We could label that this is also 42 degrees, the angle of elevation from the boat to Matt. We could also calculate this other inside angle here. 90 minus 42 would actually give us 48 degrees. So depending on what relationship, which angle we want to use, we could use a different relationship, right? If I use 42 degrees, I would use the relationship between 305, and x. If I use that 48 degrees, I would also use that relationship there. I am going to choose to use the 48 degree angle, but you could do this another way and verify that we get the same thing. So compared to that 48 degree angle, x is the length of the opposite side, and 305 is the length of the adjacent side. So once again, since I have the opposite and the adjacent side that I'm dealing with, I know that I'm using tangent here. So the tangent of 48 degrees must be equal to x divided by 305. So once again, I'm trying to isolate x. This time I'm going to multiply by 305. And so I'll get that x is equal to 305 times the tangent of 48 degrees. And again, using my appropriate calculator in degree mode, I'll get x is approximately 338.737 feet. So that would be the distance of the boat from the base of the cliff. So from here, I think there are three practice questions, and the really, really important thing to pay attention to is what information you're given and what information you're looking for. And again, I think drawing a picture is really helpful here, just to be able to visualize which side is opposite, which side is adjacent. Maybe I'm dealing with a hypotenuse instead of a leg. So Try these out. Remember the difference between angle of depression and angle of elevation. Do your best and check in with me if you have any questions. Have a wonderful rest of your day.